Thank you very much. Good afternoon, ladies and gentlemen. I'm very impressed, very honored and very impressed to make this presentation in this theater. I don't pretend to make the show, and it remains a challenge to, in 30 minutes, to make a presentation about all the progress, achievement of the last years in waste management. We prepared the presentation in 3 parts. I will start with waste produced in operation, either low-level or high-level waste. Then in the second part, I will move and show you some insights about dismantling and decommissioning, and in particular the new challenges we have to face in this field. And everyone should remind that whatever you are thinking about nuclear future, you have to deal with waste, and in particular waste coming from the decommissioning. And this is really a common challenge, whatever you are thinking about nuclear. And in the third part, I will make some short remarks about waste coming outside of the nuclear industry, I mean sources and norm, because it is an old but also an increasing topic, also in the framework of the new directives that was presented. To start with, on a global level, about nuclear waste coming from the nuclear industry. In the world, you have more than 446 reactors in operation. You have some newcomers, 4 newcomers, new countries entering in the nuclear production. So you have really an industry that have to deal with waste on a global level. Concerning low and intermediate level short-lived waste, those wastes have been properly disposed for many years now, with different concepts that you find on these slides. You have surface disposal, it's the case in France, it's the case in Spain, one will be open in Belgium. You have also shallow disposal in Slovenia, for example, with this kind of pit. And you have underground disposal in Sweden, Finland, typically, also in South Korea. Those concepts can be different, but they are all mature and all well managed. The differences can be explained by geology, of course. It's the case in Sweden, where they have only granite. It can depend also on the history, the culture. Where you have in mining culture, it's not the same thing that in a country where there is no mining culture anymore. And one important criteria from my perspective is the size of the national nuclear program. Because it's clear that it's not the same challenge when you have to deal with 8 reactors in Sweden or with 58 reactors in France in terms of industrialization, in terms of accident risks, if you have to manage an underground facility, etc. So we can explain the different choices that are made in the different countries. But basically, all those concepts are now well managed and mature concepts. Of course, there's still room for an opportunity for innovation and optimization. I will come back on that later when I will talk about decommissioning, but basically it's mature technology. Yes, concerning high-level waste and spent fuel, it depends on the political choice that has been made in terms of reprocessing and cycle, it remains a challenge, of course. It is a challenge with significant progress in the last years. It was explained by Mr. Gariba concerning the 3 frontrunner, France, Sweden, and Finland. I will come on that later. But basically, in this field again, there has been much progress on the scientific field for the last 40 years. For more than 40 years, many different scientific research competencies have been mobilized, mainly on long-term safety, and now we have the scientific knowledge, they are available, feasibility has been clearly established, and science and research are more and more oriented on technological topics, industrialization and operational safety. Because before having long-term safety, you need to have, first of all, operational safety when you operate those facilities. And now, if there is, and there will remain, political debate, social debate in society, they are really more oriented on ethical questions than really scientific questions about geology. it's more a question choosing between geology and society than really having a scientific debate about the scientific aspect of those projects. So where are we now on a more national overview, in a more national overview? As I was saying, there are 3 countries that are, I would say, the front runner in this field and that have a detailed design and are applicating or having already a license for construction. It's very important to say that we are 3 frontrunners because I wouldn't be very pleased to be completely alone as a French in this field, and I think exactly the same in Sweden and Finland. And to be 3 projects more or less in the same dynamic, I think it's better for everybody. So Finland has a construction license for now 2 or 3 years, and they started construction. They have other steps in terms of licensing for the operational and nuclear part, but they started construction in Onkalo. Sweden has applied with a detailed design for a license in a quite complex regulatory framework with both a nuclear and an environmental licensing process, which remains a bit complex because it had some agreement from the nuclear part and some still discussion from the environmental part. But as far as I understand, they expect to go a little further in the next month. And France is just about to complete the detailed design we started in 2011 for the end of this year. And then in 2020, we will applicate for the licensing process to the Nuclear Safety Authority, so in 2020. Other countries, and these are also on this slide, are restarting or implementing a siting process. For example, in UK, they restart at the end of 2018 a siting process on a very broad base in UK. Switzerland is implementing also an impressive program based on a roadmap, a very strict roadmap, and a very strong democratic process. I would say in a very Swiss way of life, because there are many interactions with population on all the impact and the aspect of such a project. And other countries are also trying to restart or implement a siting process. I'm thinking of Japan, of course, which we started the process 1 or 2 years ago. Belgium, which has made a long process with its laboratory. And more generally, there are around the world several underground research laboratories, Belgium, Hungary, Switzerland, Japan, which are very precious from a scientific point of view, but also from a political point of view to have something to show to the stakeholders concerning deep geological repository. But science and siting is not the only challenge that we have to face. And from France, I can really confirm that because we are more in an implementing process now with design, conception, and then licensing. And those phases also, and this next slide, are also very challenging. Most of the time when we are talking about deep geological repository, we are talking about policy framework, we are talking about site evaluation, science, site selection, characterization, and then we are thinking that because we are relying on very robust technology, design, construction, permitting will be an easy task. It is not absolutely not the case. Those projects are always very, very long-term projects. And it has many implications. Implication in terms of development and construction. Some part of those facilities will be built in a few decades. So it is a constraint, but also an opportunity in terms of innovation. And long-term operation, probably more than a century. It's the case in France, it will be the case in Germany. So more than a century, it has implication in terms of project management. The first one is that you have to remain very flexible, very adaptable to technological innovation, of course, but also to policy change, energy policy change, lifetime expansion of nuclear power plant, evolution in the cycle policy, reprocessing, no reprocessing, fourth generation, no fourth generation. So you have really to be very flexible and adaptable in the implementation and the management of your project. It has also implications in terms of knowledge management, because it means at least 4 generations, I will even say globally 5 generations, because we started 25 years ago, where really change in terms of knowledge management, not only within our institutions, typically my agency or in research institutions, but globally in the community, there is a real change of knowledge management on the very long term. And the third challenge is that every phase is a challenge. Every change of phase is a challenge. When we started to make design, we had to change the agency to adapt it itself to engineering. And we had 7 years of engineering, which will finish at the end of the year, this year. And implementation, construction is another change, and that we know that we have once again to change to become a contracting authority, a nuclear operator, in front of nuclear safety authority, and it will be also a great change. So there is much to do, phase by phase, and many challenges to solve. This was my first part on low-level and high-level waste from operation. Now I would like to move to new challenges linked to dismantling and decommissioning. Mainly, we're talking about low and intermediate level waste, and mostly short-lived. I don't take in discussion the very complicated facilities from the research sector. But mainly, most of the waste that we have to deal with are coming from NPP, and they are mainly low and intermediate level waste. So, from themselves, there is no scientific change by themselves. They are not very dangerous, they are intermediate. But the process has to be industrialized, and we are facing with huge quantity, sometimes also huge diversity, with change in terms of characterization. And there is a question more globally of optimization, industrial and environmental optimization in terms of decommissioning strategy and disposal concept. And we have to find this optimum in terms of a social optimum, in terms of budget allocation. And in this field, one of the challenges, sorry, it shouldn't be white. So it's one of the difficulty is the incertitude in terms of amount of waste. It is linked to question of characterization, but also linked to safety requirements, depollution targets, and disposal strategies and technology. Do we sort the waste? Do we monitor them properly? Do we reuse part of them? Do we recycle a part of them? Or do we put them all in disposal directly? This question of quantity, this question of global strategy has to be solved if we want to find this optimum I was talking about. Of course, a source of optimization could be, like in non-nuclear waste management, to implement reuse and recycling strategy. UK has been a leader in that field because it had many constraints in terms of facility in UK. But for that, you need really to reuse materials or waste outside of the nuclear industry. It's a question of clearance level, which is a difficult topic. It's not only a question whether you have or you don't have a clearance level, but because even when you have clearance level, it is more and more difficult to implement them. Every year, you are asked more control, more monitoring by safety authority if you want to obtain the clearance and the reuse outside of the nuclear field. So the question is really a question of social acceptance. Typically in France now, we have a national debate, and a part of the discussion will be about social acceptance of reusing old materials outside of the nuclear sector. Social acceptance and demonstration how you are controlling the waste, the characterization of the waste, and how you're building confidence. And in particular, if there is a failure in monitoring and controlling. That is partly a technological question, and there is room in this field also for improvement research on technological field, methodology, probabilistic approach, pre-treatment, in relation with the regulatory framework. One specific focus on a specific category of waste that we call the low-level, long-life waste. Basically, mainly, we are talking mainly about historical waste. Typically, graphite coming from the graphite gas called NPP, or radium-bearing waste coming from the chemical industry. The question on this category of waste is that they are not very dangerous, they are really low level, very comparable with waste that we are putting today in surface disposal. But they have a long life. So it means that after 50,000 years, they can remain radioactive on a certain level. So we have to find a proportionate solution which is not absolutely the deep geological disposal, which is too much, but can't be the surface disposal. So we are looking around something, a proportional option that would be a low depth, a shallow disposal. But how to make a concept and demonstration, safety demonstration that is acceptable for this kind of waste. I was talking about historical waste, so there are not so many waste basically. Graphite, it is for the country, UK, France, that has been operating graphite gas called MPP. Radium-bearing waste, it is linked to specific sector of the industry and the chemical industry. But in reality, they are not alone, those waste, low-level, long-life waste. They have some cousin, some other members of the family. A part of old waste that are low-level but bituminized coming from the research sector, but also some uranium-bearing waste, some uranium, depleted uranium, which is considered today as a material, but could be one day considered as a waste, and many a norm, that is radioactive waste coming from the industry. So the quantity of the problem must be much larger than the original graphite and radium-bearing waste we were considering a few years ago. And in fact, this question is much larger and is really quite a complicated question. When we are talking about shallow disposal, technically there are some different concepts. You can imagine an open pit and with a cover, man-made clay cover after. You can imagine also on a low depth an underground drift a few dozen meters under the surface. But it's not that point that is essential. The essential point is that a shallow disposal, which could be a part of a portfolio of options to deal with those waste, is an intermediate solution. It means that it can be very safe at the beginning, but you can't prevent, in 50,000 years, you can't completely prevent erosion and intrusion. So there is a part of scientific question, but also a question which is a question, more social question, which is a kind of remaining risks you accept to transfer to those long-term generation in 50,000 years. This is the first question. The second question is a budget allocation that you are deciding today for those waste compared with other used, which could be have more priority in terms of radioactivity. And the third point is the kind of national and debate you have to have with the stakeholders of any kind to build and to co-construct a common strategy. I insist, and I will stop now on this category of waste, because it's not only a question for the nuclear industry, it can be more general for a large part of the industry which has waste with a certain level of radioactivity. And it's directly linked to the evolution of the directive framework of the last years. To finish, in my third part, I would like to give some remarks about waste coming outside the nuclear industry I'm thinking about norm and sources. And one shouldn't forget them, because for them, the context is quite different. It's quite different because they're produced in many, many different countries by non-nuclear industry and non-nuclear country. It means that they're present in many countries with low and even sometimes no nuclear culture. So it's also a challenge and an opportunity for our community to find and to help to implement proper options for these waste. Proper options, it means safe, environmental safe, but also affordable and very simple to implement in countries with no nuclear culture. There has been already some international cooperation in that field. I'm thinking particularly of a working group by the International Agency in Vienna. My agency is taking part in this work. There are also work at European level on that field. It's really essential to be able to offer solution for those category of waste. Sources, but also norm in relation with my former point. I'm coming now to the conclusion. You will see in the slides, but I will not comment then again, in the conclusion, a summary of what I was saying about a low-level waste, high-level waste, and the new challenges in terms of decommissioning. And I will finish with two remarks on cooperation. Of course, there is a strong need for international cooperation. On a multilateral approach, with IAEA, of course, NEA, with the European Commission, it's quite essential to have frameworks, to have common standards. It is also essential to have bilateral cooperation with other countries, other agencies, in order to have benchmark, but also in order to be able to explain every time the differences between our different projects. Because you saw that there are some different strategies. Those differences can be explained. They can be explained by history, by geology, by industrial dimension and aspects, but one has to be able to explain. Because we have all a common responsibility, and at the same time we have a national responsibility. And I will finish with a last remark, which will be linked with other session in this conference, which is the involvement of the European Commission in terms of research and development. This support by the European Commission is essential. We move progressively to a much more integrated and strategic approach, and EURAD is really an achievement. It is an achievement, but also a new starting point, and I wanted to finish by that. We're talking about that with Christopher Davis, because it's really a common involvement of the national member state and European Commission, which made it possible to launch this initiative of EURAD. And what is new in this program, from my perspective, it is that it relies on a few essential principles that are important for research and development, but more generally for waste management. First of all, to deal with all radioactive waste, it's essential to have the complete scope in order to implement proportionate solution. The second point is to have a comprehensive overview of the treatment, of the different treatment routes, pre-treatment, treatment, and a final disposal. And the third point is to have a federation of all the actors. It means, of course, waste management authority, regulators, national authorities, but also TSO, research institute, and links with industry and the civil society, because for every time, at the end of the day, it's also a question of social acceptance and understanding by the population and stakeholders. Thank you very much, and I'm open for questions during the panel. Thank you.